Okay, so today I would like to talk about the different types of sources. But before I start talking about different types of sources, I'd like to remind you that we have voltage source and we have current source. What is the difference between both of them? The voltage source, like what is written in the notes, is a specific element that will maintain a prescribed voltage value. This is the voltage source. And the current source is an element or source that will maintain a prescribed current value. This is the difference between both of them. But if I asked you about different types of sources, generally speaking, I can say I have two different types of sources. Number one, independent sources. Number two, dependent sources. What is the difference between both of them? The difference is the independent source is a specific type of sources that will have a prescribed voltage or current which is not depending on any element in the circuit. And we are representing those two by using this guy for the voltage source and this guy for the current source. This is V and this is I. So it is represented by circle, for example. But if you are talking about dependent sources, what are those? Those are some sources that are depending on the current or the voltage at a specific branch. So if I'm talking about, for example, dependent voltage controlled voltage source. We are calling it dependent voltage controlled voltage source. What is this guy? This guy, it is voltage source. It is controlled voltage source. Depending on what? Depending on voltage. So its symbol will be something like that. Vs is equal to a certain value multiplied by the voltage for a specific branch. Imagine, for example, I have a certain circuit. And I have that dependent source that is represented by parallelogram, not circle. And this guy, its voltage value, its voltage source, is equal to constant, which is mu in our case, or 5, or 6, or 7, multiplied by the voltage for a specific branch. This is what we are calling dependent voltage source, and it is depending on voltage. I'll show you an example in a few seconds. The second type is voltage source as well, but it is depending on current, and it's called dependent current controlled voltage source. So this guy is something like that. Its voltage value is equal to constant P or whatever multiplied by the current for a specific branch. It's voltage source, but it is depending on current for a certain branch. The third type for dependent sources is dependent voltage control, dependent voltage control current source. So this guy is something like that. This guy is current source, but it is depending on voltage for a specific branch. So it should be written like, for example, IS equals alpha, which is constant, multiplied by Vx. And the last one is dependent current controlled current source. And this guy is represented by something like that. It is current source, but it is dependent. Its value IS is equal to constant beta multiplied by the current for a specific branch. We are not understanding what you are talking about. Let me give you a very simple example to clarify what I'm talking about. Imagine we have this circuit, for example. This is 50 volts. This is 20 ohms. I have voltage here, which is equal to whatever value, like 10 ohms. And this guy is V1, for example. And we have resistor here, which is 12 ohms. And we have another resistor here, which is 30 ohms. And I have a current source here. This guy is equal to 5 Vx. And I would like you to let me know how many sources do we have in this circuit? How many sources? I have two. The voltage source, which is 50, this guy is dependent or independent? Independent. Yes. And I have 5 Vx. This guy is dependent or independent? Dependent. Is it a voltage source or current source? It's current source. Yes. How did you know that? Because I have arrow. Arrows representing that guy. But how come I have 5 Vx? Yes, 5 Vx. This is Vx. Which means this guy is dependent current source. It is depending on the voltage between these 2 points. That's why it is function of Vx. I can have voltage source, which is depending on voltage. I can have voltage source, which is depending on current. I can have current source, which is depending on current. So generally speaking, I have two different types of sources, the dependent and the independent. The independent could be voltage or current, and the dependent could be voltage or current. But it could be voltage depending on current or voltage, or current source depending on current or voltage. Any question for that? Yes. Yes, go ahead. Is that what? Is that a multiplier? Yes, 5 Vx. Like for example, the current or the voltage for that branch, its name is Vx. So the voltage source will have a current value which is equal to 5 times that voltage. Now, let us talk about two different types of elements in any electric circuit. We have active element and passive element. So types of elements in any electric circuit. I have active element and passive element. What is the difference? The difference is the active element is any element that will generate power. The active element is any element that will generate power. What about the passive element? It is absorbing the power. So let us go back to the active element. The direction of the current for the active element is from high to low or from low to high? For active, it is from low to high, like the pump. Don't forget, current looks like water. So if I'm using pump, I'm forcing water to flow from low to high. So if I have active element that will generate power, it will force the currents to go in opposite direction from low to high. But the passive element, like resistor, the current is from high to low, like the regular case in case of a flowing of the water from high level to low level. Based on that, guys, I can say the types of elements, and this is very, very important. In any electric circuit, I have two main types. The first type is called active element. So for the active element, you told me that it is the element that will generate power. My question right now, this could be resistor. It could be inductor. It could be capacitor. Could it be voltage source? Is it dependent or independent? It doesn't matter. So this guy could be voltage source or current source, dependent or independent, it doesn't matter. But at the end, I have a condition. What is that condition? The condition is for this guy to be an active element, it should generate power. And the condition for generating power, the direction or the current will pass from low voltage to high voltage. So if you would like to see the direction of the current for this guy, it should be upward. If you would like to see the voltage across I, it should be something like that. And by the same way, this is the direction of the current, and the voltage across this guy should be like that. Again, for any active element, the current will pass from low voltage to high voltage. If it is opposite, it is not active. Oh, do we have source which is not active? You are saying voltage source or current source, and you are saying there is a condition. Are we expecting that there is a voltage source or a current source which is not active? Yes or no? Some of you are saying yes, some of you are saying no. Okay, I'll give you a very simple example to correct yourself. If we are talking about two different cars, one has dead battery and another one has live battery. So I asked John to come and help me, because this is the example that I said yesterday. Because my car has dead battery. So he connected his battery to my battery, and the current will start to flow from his battery to my battery. And then the direction of the current inside my battery will be from positive to negative. But for his battery, from negative to positive, right? So my battery right now is active element or passive element? Yes, it is passive element, but his battery, it is active. So based on that, the source could be active or the battery could be active or could be passive. Yes, it could. You have a condition. If you would like to look to that source or that battery to be active element, you have to have current that will flow from negative to positive side. If it is opposite, no, this is not active element. At that time, if this guy is not active element, should I consider it as absorbing power or generating power? It is absorbing power. Like my battery was absorbing power, but John's battery was generating power. So if I asked you about the sign of the power for my battery, which is dead battery, is it negative or positive? It is positive, but for John, it is negative because it is generated power. But for my battery, which is dead battery, it is absorbed, so it has negative sign. Sorry, it is positive because it is absorbing power. So if the power is absorbed, the power should be positive. If it is generated, the power should be negative. Any question? Let us move forward to the passive elements. So for the passive elements, you are talking about maybe resistor, maybe inductor, maybe capacitor. But there is a condition for that. Any resistor is passive, but you have to pay your attention. If this is the direction of the current, there should be positive sign here and negative sign there. Positive and negative, positive and negative. So this is L, this is C, and this is the direction of the current for all of them. From high to low. The current is flowing from high to low. Also, if I have something like that, my battery, which is dead battery, if this is the voltage V, and I found that this is the direction for the current, this guy is considered as active or passive? Yes. If I have something like that, this is I, and I have negative, and I have here negative positive. This guy is considered as active or passive? Oh, you are seeing current source and voltage source, and they are passive. Yes, like my pattern. This guy could be dependent, could be independent, it doesn't matter. But generally speaking, I can say here for active element, the direction of the current is from negative to positive. But here, the direction of the current is from positive to negative. Again, if you are talking about active element, the power is generated. If you are talking about passive element, the power is absorbed. Any question for that simple thing? Yes, go ahead.
If a capacitor or an inductor or having current run from negative to positive, that make it active or is it still passive?
So generally speaking, if you are talking about inductor or capacitor or resistor, we are considering them as passive elements. And the direction of the current will be from positive to negative. When we will talk about the inductor and capacitor as a storage element, I will clarify something else. Because if you are talking about storage element, which is the inductor or the capacitor, at that time, this guy is a charging and then this is charging. This is another story. I'm talking right now about L and C as if we have L and C like resistor, which is passive element. Any question? These are very simple things, but they are very, very important. If you understood these simple things, everything will be very easy in electric circuits. I didn't start talking about any problem, but these are basics for any electric circuit. Let us see the first rule or the first theory here, which is Ohm's law. Ohm was a scientist, and this guy was working in his lab, and he tried to find the relation between the current and the voltage across a specific conductor. And what he found, he tried to draw the relation between V and I. And Ohm found that by changing the value of I, the value of V will be changed or vice versa. But he found the relation between V and I is approximately linear relation, which means I have a straight line that will describe the story between V and I. As you are increasing V, I will be increased. Then Ohm said, based on that, I can say the voltage is equal to the current multiplied by constant value, which is the slope for that straight line. And he called that slope as a resistance. So Ohm said V is equal to I times R inside any conductor. And Ohm represented that by this symbol. And he said, if this is R and this is I, there is a voltage here V. Since Ohm described that story, so he doesn't like anyone to forget his name. That's why he put the unit for the resistor R. He called R as resistor, and he put the unit for R as Ohm. Like that. P is equal to I times R in any circuit. Then he said also there is something else which is called G, and he said G is called conductance. And he said G is equal to 1 over R. And based on that, the unit for this guy is the reciprocal of Ohm, which is something like that, or MHO, mho. Or he gave it another name, SIMENS. So you can use this unit or that unit or that unit, it doesn't matter. But at the end, G is the conductance, which is the reciprocal of R. So from that story, what do I like to know? I'd like to know very simple thing. Number one, V is equal to I times R, and this is the very simple equation in electric circuits. And we studied that in physics. Number two, the resistance is represented by unit, which is called Ohm, and the reciprocal for the resistance is G, which is 1 over R. Now, let us talk about the most common theories in electric circuits. Kirchhoff is voltage law and current law. So Kirchhoff is one of the most laws that we are using in electric circuits. But before I start talking about Kirchhoff's laws, I'd like to distinguish between two different things. Number one, what is the difference between nodes and loop? It's very, very important to understand that. Let me give you a very simple example like this circuit. This is R1, this is R2, this is R3, this is R4, and this is V. So any closed path is called loop. Any closed circle is called loop or path. Based on that, how many loops do we have? I have 1, I have 2, and I can consider the outer loop also. So if you are talking about how many loops, I have this guy, I have this guy, and I have the outer loop as well. But generally speaking, we are using the two inner loops for most of the problems. Now, let us talk about nodes. What is the meaning of nodes? Before I start talking about the nodes, I would like to define what is the branch in any circuit. So any element is considered as a branch. So this guy is branch, this guy is a branch, this guy is branch, this one is a branch, and so on. So what is the node? The node is, this is the general meaning, is the point of intersection of two branches. It is the point of intersection of two branches, right? This is the general meaning for node. So how many nodes do we have for this circuit? I have actually 1, 2, 3, 4, and so on. Any two branches are connected together, it could be considered as node. But there is another meaning for something else, which is called essential node. So what is essential node? It is the point of intersection of more than two branches. So how many essential nodes do we have? Actually, I have two. This one and this one. And this is what I would like to know. I'd like to know the essential nodes. And generally speaking, instead of talking about the node, I'm going to talk about the essential node. So if I told you how many nodes, I mean essential nodes. I don't mean nodes. Okay, guys? Because I would like to deal only with essential nodes. But for simplicity, I'm going to call it nodes. Some people are mixing between both of them, but at the end, I'm looking for the point of intersection of more than two branches. So, based on that, Kirchhoff said two different laws. So let us talk about Kirchhoff is laws. Sometimes we are calling this the laws of connections. Let us talk about the first law, which is Kirchhoff is current law. What's Kirchhoff's current law? Sometimes we are calling it KCL. Kirchhoff said, summation, the current is equal to 0 for any nodes. Summation, the current is equal to 0 for any node. This is the first law, which is KCL. Let us go back to this circuit. Now, I would like to say summation, the current is equal to 0 for that node. But actually, I don't have the current direction. What should I do? I will assume it. In any direction, yes. So I will assume the current in each branch in any direction. Am I allowed to do that? Yes. You are allowed to assume the current in any direction for each branch. But if the branches are connected in series and there is no distribution, they have the same or different current. They have the same current, which means if I assume that I have a current here, which is I, 1, the current here will be, what about the current here? It is different. Why? Because I have distribution here. Okay. Why did he assume that direction for the current? Assume anything as you like, whichever you like, assume it. What about if I solved the problem and I calculated the current and I found the current is equal to a negative value? There is no problem. It doesn't mean my solution is wrong, but it means my assumption that I assumed the current will go in that direction is wrong. Does it mean the solution is wrong? No, it means the right direction for the current will be opposite to what I have already assumed. Should I change it? No, keep solving the problem with the same direction by using the same sign, which is negative. And there is no problem at all. At the end, you will get negative value for the voltage. What does it mean? It means I assumed wrong direction for the voltage. That's okay. So don't be scared. If you got negative value for the current or negative value for the voltage, it doesn't mean you are in the wrong direction. No. It means you are in the right direction, but you assumed wrong direction. But it is okay, acceptable. So don't be scared. So what about the current in this guy? Assume it in any direction you like. So I will assume the current here, for example, as I, for example, 2. And I will assume the current here, I3. So Kirchhoff's voltage law said, Kirchhoff's current law said, summation the current for that node is equal to 0. Summation the current for that node is equal to 0. Okay. So if summation the current is equal to 0, based on Kirchhoff's current law, I can say summation all currents for that node is equal to 0, which means I1, I2, I3 should be equal to 0. Should I add them? Kirchhoff said no. You have to add some signs based on something you are going to assume it. So if you assume that the current that will hit the nodes have positive sign, so the current that will leave the nodes will have negative sign, or vice versa, as you like. So if I assume that the current for this guy will have positive sign, what about this current and this current? So I can say based on that, summation I is equal to 0, I1 minus I2 minus I3 is equal to 0. What about if I assumed different thing? If the current that will hit the nodes will have negative sign, so the current that will leave the nodes will have positive sign, what I will have negative I1 plus I2 plus I3 is equal to 0. Is it the same equation? Yes. You multiply that equation by negative 1. But some of you studied in physics. Summation in equals summation out. I1 is entering, and I2 and I3 are leaving. So I can say I1 is equal to summation of I2 and I3, which is similar to that equation. Any question? Any question for that? Okay. I think I'm sharing my screen. I'd like to be sure that I'm sharing it. I hope I'm sharing it. Excuse me?
You are, yeah.
I'm sharing it? Okay, that's good. Because I have to repeat that again. But anyway, there's no problem. I hope I'll have successful video today because I will not record it again. But let us talk about the second thing, which is Kirchhoff's voltage law. Before leaving that part, any question for Kirchhoff's current law? You are seeing these things are easy, but believe me, these are very, very important. Yes. Yes. Summation, all terms are equal to 0. So I1 minus I2 minus I3 is equal to 0. At the end, I'll have I1 is equal to I2 plus I3. You got what I mean? If you got lost while you are dealing with the currents, look again to water. I usually give that example to my students. I have water in a certain pipe, and this water is distributed into different amounts because the pipe is distributed. So summation amount of water in should be equal to summation amount of water out. Am I right?
Yes.
Now, let us talk about the other nodes. Summation the current for that node is equal to 0 because I'm concerned with these two essential nodes. If I say summation the current for that node is equal to 0, I have this current, which is what? What is this current, guys? It is I1. What is this current? So if I said summation the current for the bottom node is equal to 0, I have I2 and I3 are hitting the nodes, and I1 is leaving. So I'm going to write my equation as I2 plus I3 minus I1 equals 0. What is the relation between this equation and this equation? They are the same because of symmetry of the currents. So please try to avoid repeating, writing summation I is equal to 0 for symmetrical nodes, currents. Try to avoid that because what you are going to do, you are going to repeat writing similar equation. And then maybe you will have like 5 equations in 3 unknowns. And you will be scared. Why? Oh, I have 5 equations. How come I'm going to solve them? I'm getting lost while I'm solving 2 equations and 2 unknowns, but right now I have 5. How many unknowns do you have? So try to think about that. So if you try to minimize the number of equations, everything will be very easy. But if you try it to increase the number of equations, everything will be hard for you because I think you studied applied linear algebra, right? In applied linear algebra, you were using Gauss elimination method, or I don't remember the 2 methods for solving 2 or 3 equations by using matrices or something like that. And it was hard. Am I right? By using like reduction method or elimination method, whatever. Imagine you have 4 equations. Is it easy? So try to think about that. Maximum, try to think about 3 equations in 300. And I will try to do my best to minimize the number of equations for the exam's problems. So let us talk about the second law for Kirchhoff. Kirchhoff is voltage law. What's Kirchhoff's voltage law? Kirchhoff said, Kirchhoff was drinking tea and he was thinking, oh, I have a specific loop. So summation V for any loop is equal to 0. But many of you are being scared while I'm talking about summation V is equal to 0 for any loop because many of you are making mistakes. Why? Because they are not understanding well how to deal with that. Let us go back to that equation or to that loop. Now what I have V and I have this guy and I have this guy. So the voltage drop across R1 is equal to what? I1 R1. And the voltage drop across I3 is equal to R4, sorry, is equal to what? I3 multiplied by R4. But before I start writing these equations, you have to put the signs for the voltage drop. The sign for this guy will be positive, negative, or negative, positive. It will be positive, negative. Generally speaking, if the current is entering the resistor, it is leaving at the beginning positive sign, and it is leaving at the end negative sign. Now, let us talk about R4. I will have positive, negative. Kirchhoff said what? Summation the voltage for this loop is equal to 0. Okay, so I will say this voltage, which is V, and this voltage, which is I1 R1, and this voltage, which is I3 R4, equal to 0. Let me write that. So V, this is loop number 1. And I1, R1, and I forgot, is it I3? I3, R4 equals 0. But just 1 second. What is the sign? Kirchhoff said summation. What is the sign for this? What is the sign for this? What is the sign for this? Is it positive or negative? Kirchhoff said you have to go back to the circuit. And you will choose one of 2 direction of rotation around the circle. I will rotate around the circle clockwise or anti-clockwise. It doesn't matter, as you like. But I have to have one direction for each loop. If I have 2 different loops, should I have the same direction? No. You can choose a certain direction for that loop and another direction for that loop. But for the loop itself, for all the branches, you have to have the same direction. So I have a specific loop. I'm going to rotate in that loop anti-clockwise or clockwise. And Kirchhoff said, I will keep the second sign or the first sign for each branch while I'm rotating. So I have a certain voltage and I'm rotating in that direction. If this is negative and this is positive, the second sign is positive. Are you seeing what I'm talking about? Let us go back to this loop, which is loop number 1. So if you are talking about loop number 1, this is very, very important to understand. Many of you are mixing that. And this is the key for solving any electric circuit problem. So you are rotating in that direction, which is clockwise or anti-clockwise. This one is clockwise. You are going to keep the second or the first sign for each branch. What do you like, the second or the first sign for each branch? Which is which? The first, I'll keep the second. So I'm rotating anti-clockwise and I'll keep the second sign. The second sign here is positive. And I'm moving in that direction. The second sign is negative. And I'm moving in that direction. The second sign is negative. Are you seeing what I'm talking about, guys? So I'll go back and write that. Positive, negative, negative. And this is the key for solving any electric circuit problem. If you understood what I'm talking about, electric circuits till the end of the term will be very, very easy. This is very, very important. Many of you are mixing between the signs. Why? Because many of you are memorizing. They are not understanding. But if you try to understand, everything will be very, very easy. Do you like me to repeat that? So what I'm going to do is I'm trying to rotate clockwise and I will keep the second or the first sign. Let us repeat that case by choosing the first sign. So I'm rotating in that direction. The first sign here is negative. And I'm moving this way. The first sign is positive. And I'm moving that way. The first sign is, so I'll go down and put here negative, positive, positive. Oh, do I have the same equation or different? Yes, you multiplied it by -1, which is okay. Let us do the same for the second loop and I'll listen to you. Let us do the same for the second loop. So the second loop is this guy. I'm rotating here also clockwise or anti-clockwise. It doesn't matter. So let me put the signs. I have positive and I have negative. And I have positive for this and negative. Am I right, guys? And I have positive, negative because of the direction of the current. So my friend, you would like to keep the second or the first sign that you would like to ask a question. The second sign. So while I'm rotating, the second sign for this branch is. Okay, so I'm rotating in that direction. So I was here and this is negative and I'm moving, the second sign is positive. Then I'm moving again with the second sign, then I'm moving back. So here in this circuit, I was at R4. I started from the bottom. So the first sign for me is negative. I'm going up to positive, so the second sign is positive. Then I will turn right. The second sign is, and then I will turn right again. The second sign is. Did I answer your question? Okay. So this is his question. I know. I was reading it from his eyes. So this guy is positive, negative, negative. Which means I can say this voltage, which is I3, I4, minus this voltage, which is I2 multiplied by R2, minus this voltage, which is I2 multiplied by R5. So I will say here, summation V is equal to 0 for loop 2. I will have positive, I forgot, I3, R4, right? Minus I2 times minus I2 times, is it R2 or R3? I didn't write R3, that's okay. I don't have R3 here. I have R5, that's fine. So this guy is equal to 0. I'm tricking you. Any question for Kirchhoff's voltage law and Kirchhoff's current law? Yes. Could you please raise your voice?
The direction of the current doesn't have to be the same as the loop
It
direction.
doesn't matter. He is asking about the direction of the loop for the rotation and the direction of the current. It doesn't matter. You will rotate in a specific direction and you have the signs for each branch. Let us see two different problems which are talking about that story. But before start seeing these problems, I would like to talk about one more thing, which is open and short circuits. Then I will solve some problems with you. So let us see what is the meaning of open and short circuit. So open circuit and short circuit. What is the difference between open and short circuit? Now, I asked Andy, right? Andy? So I asked Andy, can you please take this wire? Its resistance is 0. Please go to that socket and connect it. What's going to happen? Here's my friend. What's going to happen to him? He connected, he went to the socket and he used the wire that I gave it to him and he connected it and he is being happy, he is holding it. What's going to happen to him? Excuse me? It is short circuit. Probably we're going to lose something from him. I don't know what. But what's going to happen, this is what we mean by short circuit. I am connecting a wire without resistance across a specific branch. This is short circuit. So what I would like you to know for the short circuit, if I have this circuit, for example, and I connected this wire, this is, for example, 100 ohm, 200 ohms, 50 ohms, this is whatever, 150 ohms. What I did here, I connected that wire that has no resistance. What's your name? What's your name? Press. Now press, I'm connecting this wire that has 0 resistance in parallel across 150. Okay? The current is smart. current is thinking. So the current here is looking to these two branches. And the current is trying to be distributed between these two branches based on the resistance value. So if the resistance is equal to 0 for the short circuit, are you expecting all currents? The current in like 200 ohm will pass through this wire, or part of the current will pass through 150 for the wire, because the current is smart, like you. What is the meaning of short circuit? Imagine we are in this room, and we have two different doors. We have this guy, and we have the other guy. And the other door is locked. Why? Because it has resistance. But this guy is open because it doesn't have resistance. All of us will go through this door or this door, because both of them are connected in parallel. So, generally speaking, if you have a wire without resistance connected in parallel across resistor, this is short circuit. What's going to happen? No current will go through this guy. And all current in 200 ohms will go across this guy only. What is the meaning of parallel? Parallel means I have two branches. I can hold both of them between my hands, between two hands. This is the meaning of parallel. Again, parallel means what? I have two branches, and I can hold both of them. This is parallel. They will have the same voltage, but they will have different currents. What is the meaning of series? Series means I have two branches connected beside each other, and there is no distribution. There is no essential node between both of them. Like what? For example, like nothing in this circuit. We don't have any series. But do we have parallel? Yes. We have the short circuit in parallel with 150.
The source and the first resistor is in series.
Yes, but I'm talking about resistors. Yes, you are right. The source is connected in series with 100 ohms. Yes, thank you. Who's talking? You? Who's talking? Who's saying the source is connected in series?
Oh, no, that wasn't me, sorry.
What's your name?
Claire.
Claire?
Yeah.
Okay, because I would like to remember the names. So, like what Claire said, I can say 100 is connected in series with 10 volt, but actually I'm talking about resistors. I don't have any resistor connected in series here. Like what Chris told me, the current here will prefer to be there. What about the current here? IR, it is equal to, yes. What about the voltage between these 2 points? Excuse me? It is equal to 0, or it's equal to value?
0.
It's equal to 0. So, if you are talking about short circuits, the voltage across the short circuit is equal to 0. But the current is equal to a specific value. What about the power from the short circuit? 0, because the power is equal to V times R. So the power will be equal to 0 because the voltage is equal to 0. If I have short circuits, can I ignore this resistor because of that short circuit? The answer is yes. So you can redraw this circuit to be like that. Okay. Now, what about, this is called short circuit. What about open circuit? Open circuit, like for example, something like that. This is open circuit. I have open branch. If I asked you about the current in this guy, for the open circuit, the current is equal to 0. But what about the voltage between these 2 points? Do we have voltage? Yes. How come? It's open circuit as a proof. This guy is considered as open circuit. But if you try to measure the voltage here, there is voltage or there is no voltage? There is voltage. So for open circuit, I can measure voltage. But what about the current? There is no current. Any question for that? Yes.
I have a question for the drawing. Why is the second parallel ignored, but not the first one with the
150 is ignored because of the short circuit. The short circuit is ignoring it.
Oh,
Right now, I don't have any short circuit. 200 is connected in series with the wire. So I couldn't say short circuit. Short circuit means I took a specific branch and I connected wire without resistance. Now, let us solve some problems related to what I have already covered. Let us solve this problem from the notes. So for the following circuit, this is Vs, this is 5 ohms, this is 10 ohms, this guy is V10, its name is V10 for the resistor 10. And this guy, its name is V5. And he's telling me that the current in this circuit is equal to 2 ampere. What's needed, calculate Vs. Do you have a question? Or you are talking? If you have a question, I'm here. Yes, go ahead.
Why on the right side is the negative on top and bottom?
You are talking about V10? I gave you that name by that sign, and I would like you to calculate it. So I'm asking you to calculate Vs, V5, and V10. This is my question to you. I would like to calculate those. It's not a given value, it's unknown. Now, I would like to calculate all of these values. Let us talk about that circuit. It's very simple circuit. How many loops do we have? How many loops do we have? Essential loops. I don't have essential loops, so no need to say summation of the current is equal to 0 because how many currents do I have? 1, which is 2 amps. So if I asked you, my friend in the back is telling me why you are putting negative and positive sign here. You didn't teach that to us. You said if the current is in that direction, I will have positive and negative. But why you are putting negative and positive? Because I would like you to write that V10 is equal to negative value. I'm tricking you. Okay? So I will not look to what you are asking me. I'm going to solve the problem based on my understanding. My understanding is saying, if this is the direction of the current, I am expecting positive, negative. And I am expecting positive, negative. But you gave me opposite sign. So you would like me to express the voltage across 10 in a certain way, which is negative 5 times 5. You know what I mean? So now, if I would like to find the value of Vs, Vs is equal to what? Actually, I can say summation the voltage for that loop is equal to 0. But which sign should I keep? Should I keep the sign that you give me or the signs, the blue that I added them to the circuit? I'll keep the signs that I added to the circuit while I'm calculating Vs. Okay, I have this loop. I will say summation V is equal to 0 for that loop. The second sign is positive. The second sign is negative. The second sign is negative. Based on that, I can say Vs minus 5 times I minus 10 times I equals 0. What is I? It is 2. So I can say Vs is equal to 5 plus 10 multiplied by I, which is 15 times 2, which is equal to 30 volts. Am I right? Let us go back to the voltage V5 that you are asking me. Actually, V5 is the voltage across the resistor 5 ohms. So I can say V5 is equal to 5 times I, which is 10 volts. But what about the voltage V10? Actually, V10 is the voltage across the resistor in opposite direction. Why in opposite direction? Because I know the voltage here should be positive, negative, but I'm not asking you to calculate that voltage. I'm asking you to calculate that voltage, like in the lab next week. While we are talking about Kirchhoff's laws, I'm going to ask you to go to the lab and measure different voltage with different directions. And some of them will be negative. Because I forced you to use a specific direction. So if you would like to measure V10, it is equal to here, V10 is equal to 10 multiplied by I with positive or negative sign, which is equal to 10 with negative multiplied by 2, which is negative 20 volts. Any question for that, guys? Yes, go ahead. Please raise your voice.
How does he get current?
He gave it to me. It's 2 amps. Yes. Yes. Please raise your voice. I'm not hearing. Is what is necessary to use what?
I mean, I want to then necessary to or that loop for the current, or I just create like a prompt.
I didn't hear you, so I'm going to be beside you. What are you saying?
Sorry, I just want to know like that a song current that orientation.
Yes.
But actually that necessary, so I just use the orientation.
Oh, you need the orientation for the current. No, it doesn't matter. You can assume any direction. But here I give you the direction of the current. But for the loop, you can't assume any direction. Okay? Any question, guys? Please don't sleep. We still have many things to do. Yes, you have a question? No? So let us go to another problem, which is talking about another story. Let us see another problem. For example, I give you that circuit. This is 200 volts. And this guy is R. And this guy is V1. This guy is 24 ohms. This guy is 120 volts. And this guy is 8 ohms. This guy is I3. This is I2. This is I1. And what is needed, use KCL and KVL to solve the following problem. Find the value of R and the unknown voltages and the currents. So what I would like to find, I would like to find R. I would like to find I1. I would like to find I3. I would like to find I2, and I would like to calculate V1. This problem is a good problem, and it is the first problem that we are going to solve using KCL KVL at the same time. So what is needed for this circuit? I have two different loops, and I have two different loops on the right, and I would like to solve this problem by using KCL and KVL. If you try not to use your mind, you are going to write three equations and three unknowns. And you will sit half an hour using what you have learned in applied linear algebra or in mathematics to solve these problems. And at the end, maybe you will make a mistake. But if you try to use your mind, you will minimize the number of equations. Let us see what we have to do. We have 200 volts, and we have 120 volt across 24 ohms, and I3 is unknown. So the regular keys for solving this problem, by the way, I'm coming without preparing that because I'm putting myself in your situation. I would like to think with you on how to solve that. Sometimes I'm drawing some problems during the class, and I'm started thinking with you. This is a good way to teach you. And instead of coming, oh, we will put voltage current, calculate that, and you will not learn. You will memorize. I'd like to teach you how to think in solving the problem. Solving the problem will be very easy. But from where I should start, this is the hard part. If you try to look to this problem, I'm looking with you here. Oh, right now, I will say summation the voltage for the left loop is equal to 0. And summation the voltage for the right loop is equal to 0. And summation the current for the top node or the bottom node is equal to 0. I will write three equations. Right? This is what KCL and KVL said. But if you try to look to the problem again, only 1 minute, you will save your time. Oh, it is given the voltage across the middle branch. And I know the resistance. So can I find the current? Yes. This is the key for solving the problem. So based on that, I can say the first step is for solving this problem is to start by saying I2 is equal to 120 divided by 24. If you try to calculate it, actually it's equal to 5 amperes. Right? What is the next step? Oh, you give me this voltage. You give me this voltage. Can I find this voltage? Yes, summation the voltage for that loop is equal to 0. See? I'm trying to figure out how to solve the problem. But you can write the equation, that's okay, and you will solve the problem as well. But if you try to think, it will minimize the number of equations and the number of unknowns and will save your time. So I will say summation the voltage for loop number 1 is equal to 0. So I'm rotating in that direction. I will keep the first or the second sign, it doesn't matter. The second sign here is positive. The second sign here is negative. The second sign here is negative. Okay? Chris? Is it okay? Okay. So I will say summation V is equal to 0 around loop 1. If you don't like me to say your name, let me know. That's okay, but I'm being happy while I'm saying your names and I know you. But if you don't like me to say your name, that's okay. So I have 200 volts minus V1 minus 120 is equal to 0. So I can find V1. V1 is equal to, excuse me? It is 200 minus 120, which is 80 volt. Is it positive or negative? It is positive. This is what I got. Now, can I calculate R based on that? Unfortunately, no, because I don't know R. I'll leave that. What about loop number 2? I can say summation the voltage for loop number 2 is equal to 0. So this is the direction of the current. I have positive, negative. Which sign you would like to keep? I will keep the second sign while I'm rotating clockwise. So the second sign, my friend, what's your name? No. Yes. Mo? Okay, Mo, right now, I'm rotating in this loop and I'm keeping the second sign. The second sign for 24. Yes. And the second sign for 8. Yes. You got what I would like you to know. So right now, I would like to say summation V is equal to 0 for loop number 2. So 24 times I2 minus 8 times I3 is equal to 0. Wait a second. Why you are writing 24 times I2? The voltage is given. It is? Yes, it is 120. This guy is defined as 120. So I can say 120 equals 8 times I3. Based on that, I can find I3, which is equal to 120 over 8. This guy, I believe it will be 15 amps. Now, let us go back to the problem. You would like to calculate I1. This is the last step to be able to calculate R. So I will say summation the current for that node is equal to 0. This is node number 1. This current is entering, this current is leaving, this current is leaving. So if the current that will enter the node will have positive sign, the current that will leave the node will have negative sign, which means I1 minus I2 minus I3 should be equal to 0. So if you would like to say summation I is equal to 0 for node 1, I can say I1 minus I2 minus I3 should be equal to 0. Right? Now, I know I2, I know I3, so I can say I1 is equal to I2 plus I3, which is equal to 20 amps. Once you calculated the current I1, you have already solved the problem because the next step is to calculate R. So you will say based on that, V1 is equal to I1 times R. And you know V1 here, it is equal to 80. So based on that, I can say 80 is equal to 20R. So based on that, I can calculate the value of R, which is equal to 80 over 20, which is 4 ohms. Any question for that problem? Any question for that problem? Let us solve some problems from the tutorial that I have already submitted. Let us go to the tutorial. These are the questions that I have already submitted for the tutorial. It has some questions. I will not start from the beginning. I will start from the bottom, then I'll go back to the beginning because problem 1 and problem 2 are wasting the time, and I don't like to waste the time talking about these two questions at the beginning. I'll solve them at the end. But I would like to start by problem number 3. This problem was one of my problems for the final exam. But I solved it similar to this during the class. Let us read this problem. I'm hearing some few are being scared. Oh, this guy, what are you doing with us? Please, try to be kind. Let us read this problem and see if I'm kind with you or not. By the way, I solved it similar to this problem with my students. If you try to see the previous assignments, we have this problem in one of my assignments, similar. And we have similar to this problem from the tutorial from the previous week. Let us read this problem. For the following circuit, it is so bright here, I don't know why. For the following circuits in figure 3, calculate V1, V2, I1, I2, I3, I6, I5, I7, many things. And the power generated in the circuit. The power generated in the circuit is which power? Is it the power in the resistance or the power from the supply? Yeah, I'm asking what is the power generated? Is it the power in the supply or the resistors? The supply. Okay, another question. Do you expect that this source is active or it could be passive? Could be passive? It could be?
No, because it wouldn't generate.
Excuse me?
No, because if it was passive, it would be generating power.
So this power for this guy, in all cases, it should be generated, or maybe it will be absorbed because this guy could be passive. This source.
There's no other source.
No.
What's your opinion, guys? In the back. In all cases, there is no exception. All of you are agreeing? Yes. This is the only source. From where you will get power. This is the only source in the circuit. No doubt. It is generated. So, if you solve the problem and at the end you realized that the power for this guy is absorbed, for sure you are wrong. So from the beginning, you have to be able to read the problem. But it is very complicated problem. Oh, 1, 2, 3, 4, 5, I will count. In many equations, right? But if you try to look to the problem, oh, 3 ohms has short circuit. I'm happy because I3 is equal to what? Yes. So if you try to look to the problem, I3 should be equal to 0. Let me print screen this and go back to this guy, tutorial 1. So problem 3. So I'm happy that I could cancel this guy. Now, this 3 ohm resistor is short circuited by this wire. So can I cancel 3 ohms? What's I3 equal to?
0.
So I3 equals 0 because of short circuit. And this guy is cancelled. By the same way, 2 ohms and I4 by the same way and I2 by the same way and I6. Right, guys? See the simplicity? But at the beginning, if I am in your situation, and I didn't study this coursework, and this is what I'm laying on. I'm scaring you at the beginning. Because if you didn't study with the course, you will be scared and you will leave through this. And I'm laying on that. So, if you saw something like that, you will be scared because you will imagine that this is, you didn't study. Maybe the guy who was teaching, I don't remember his name, and I hate his course. Maybe he taught us something I didn't study, so ignore this problem. See the problem? It will be very easy. I'll show you. Now, let us draw this circuit after moving these branches. So if you try to draw this circuit again, it will be something like that. Right? This guy is connected in series with that, but you forgot this guy. So we have this guy, yeah, so this guy is 6, but we have this point, which is this point. And we have this guy, we have this point. Right, guys? Am I right? And we have 6 ohms. And we have this, and we have this, we have this, this is 2, this guy is I7, this guy is 1 ohm, and this guy is 2 ohms. Leave the open circuit and don't bother yourself by the open circuit. So this is open circuit, that's okay. The voltage here is V2, the current here is I5, and the voltage between these 2 points is, this is open circuit, it's V1. Okay, now I have a current here, which is I4. And I have a current here, which is I1. Actually, this and this and this are considered at the same node. Am I right? So I can cancel these two and put only one of them. So instead of doing that, I will try to erase this part. And I will have only that. Right? Because this guy and this guy and this guy are representing the same node because I don't have any resistance in between. But if you would like to find the current in this guy, it is half of the current in this. So I1 and the current in this branch are equal, and they are equal to half of the current inside this guy. So let me call this guy by another name, which is I, for example. And after calculating I will divide it by 2 to find the current I1 and to find the current in this guy, if you want. But I don't need the current in this guy. Now, what I have these 2 resistors, and I have these 2 resistors, and I have that resistor. So I would like to calculate the current in this guy. This is 8.5. This, its name is I. So let me change this by IA, because this guy, its name is I. Okay, so now I would like to find the current I, the current IA, and the current I5. What am I going to do with you is I'm going to erase this guy because I don't need that branch, because this is open circuit. It will not make any change. At the end, you would like to calculate the voltage between these 2 points. Okay. Then I will say summation the voltage for each loop is equal to 0. And summation the current for each node should be equal to 0. But just 1 second. When I gave that problem to my students, I put them the connection in parallel and series. And to solve that problem, you have to calculate R total and then find I total and then start distributing the current by using current divider and voltage divider. So solving that problem is depending on current divider, voltage divider, and R total. But I can solve this problem by using KCL and KVL as well. So I'm going to solve such a problem by using KCL and KVL. I'm going to solve the problem by using KCL and KVL, but by using KCL and KVL, I'm going to write many equations. But if you try to solve this problem by using parallel and series, and this is what I will go to show you tomorrow for parallel and series, it will be more easy. But right now, I'm going to solve it by using KCL and KVL. Okay, so how many nodes do we have? I have this, I have this, I have this, I have this. But actually, I have two. How come you have two? Because this one and this one, there is nothing connected between them. I mean by nothing, resistor or source. So I can consider this guy as one node. Am I right? And I can consider this guy as another node. And generally speaking, if you have two different nodes and they are connected by wire without resistance, or you don't have any source, you can consider these two as one. Okay, guys? Like during the lab, I showed you that I can connect the resistor by the source by using a wire without resistance. This is the wire that we are talking about. It could be considered as node. So this guy is considered as node, and I can say summation the current for that node is equal to 0. I have current here, its name is I. I have current here, its name, for example, is I2, or I could consider it as IB, and I have current here, I could consider it as IC, and I have another current here, which is I5, which is equal to I7. Right? So I can say summation I is equal to 0 for node, for example, I'll call it node A. This current is entering, its sign is positive by assuming the current that will enter will have positive sign. And the current that will leave will have negative sign, negative IB, negative IC, negative I5 is equal to 0. Now, based on that, I can say I equals IB plus IC plus I5. And whenever I'm seeing IB or IC or I5, I'm going to substitute them. Sorry, whenever I'm seeing I, I'm going to substitute it by IB and IC and I5. I will say summation the voltage here is equal to 0. And I will say summation the voltage here is equal to 0. And I will say summation the voltage here is equal to 0. I have 3 loops. I'm going to use them. So summation V is equal to 0 for loop 1. This is the direction of the current, so I'll have positive, negative, I'll have positive, negative. Now, I will keep the second sign while I'm rotating. So the second sign is positive, the second sign is negative, the second sign is negative. So I will write 100 minus 8.5 multiplied by I minus 6 multiplied by IB, which is equal to 0. This is another equation, but I will rewrite it as 100 minus 8.5 multiplied by IB plus IC plus I5 minus 6 IB is equal to 0, and I will consider this as equation 1. It's function of 3 unknowns. And I'm going to say summation the voltage for loop 2 is equal to 0. So I'm going to use this direction. The second sign is positive. The second sign here is negative. So based on that, I'm going to say summation V is equal to 0 for loop number 2. So for loop number 2, I will say 6 multiplied by IB minus 6 multiplied by IC is equal to 0. What is the relation between IB and IC? They are equal. Based on that, I can say IC is equal to IB. So based on that, I'll go back to this equation. Go to equation 1. I will rewrite 100 minus 8.5 times 2IB plus I5 minus 6IB is equal to 0. Now, how many unknowns do we have? I need one more equation. Summation the voltage for this loop is equal to 0. If you said summation the voltage for this loop is equal to 0, you will go in that direction and you will keep the second sign. The second sign is positive, the second sign is negative, the second sign is negative. So if you try to write the equation for that, I will say summation V is equal to 0 for loop number 3. I will have positive, negative, negative. So positive 6 IC, negative I5 multiplied by 2 plus 1. I5 multiplied by 2 plus 1, which is 3. Times what? Times I5. This guy is I5. Based on that, I can say from that equation that 6 IC is equal to 3I5. Based on that, I can say 2 IC is equal to I5. Right? But I know that IC is equal to IB. So based on that, I can say 2IB is equal to I5, but I would like to substitute I5. So I will go back to this equation and substitute I5 by 2IB. So I will have 100 minus 8.5 times 2IB plus 2IB minus 6IB is equal to 0. From this equation, I can find IB, then go back, find IC, then go back, find I5, then go back, find everything else. Like what you are seeing at the beginning, the problem was very, very complicated. But after starting solving it, it became I know. Since it is the first problem that we are solving, now you get the feeling, oh, this course is hard. No, it's not hard. The course is not hard. We just started solving the problems. So by the time, everything will be very easy. This is the third problem that I'm solving. I didn't solve more problems. Let us solve more problems related to that. Do you have any question? Okay, let us solve one more problem. I know that you would like to leave. Can we have more like 20, 25 minutes? 25 minutes is okay? I know that you are so tired, but I would like to go and solve more problems. And tomorrow, during the class time, I will solve more problems from the tutorial as well. Because today I covered many things. So tomorrow I will go solve more problems again. By the way, I'm mixing between the tutorial and the class. Because it depends on what I have already covered. I didn't cover many things. That's why I tried to cover something for this.
When will we talk about writing the labs?
Excuse me.
When will we talk about writing the labs?
Soon.
Okay.
By the way, I postponed the due date for the lab. It was supposed to be this Friday, but it was typo. It is next week. Friday. So don't bother yourself. We have 2 weeks for the due date for the lab. So if I didn't talk about the lab today, talk about it tomorrow. But I will talk about it. So let us, but I would like to talk about some problems first. Let us talk about another problem. Let us see this problem. He's asking me for the following circuit, calculate the current in each resistor. This is similar to what you have in the assignment. There is a problem similar to this one. Copying and pasting, I changed only the numbers. What's needed for this problem is to calculate only the current in each branch. This is what I would like you to do. So if you try to look to this problem, oh, this guy is giving us some problems. I gave that course. No, don't give the course. I know these problems are hard. I know. That's why I'm solving them. I'm giving you different ideas. I'm not here to give you easy problems. I'm here to give you hard problems and solve them with you to be able to solve the midterms. So it's very easy for me to give you easy problems, but at the end, you are going to lose. So I'm solving all different types of problems, easy and hard problems. And for the midterm or the final, the problems will be a bit. And I will talk about the midterm or the final, don't worry. Everything I'll cover in details. You are going to the midterm and you will not see anything in it. Everything is covered. Let us see this problem. Oh, 5 ohm resistor hanging up and 5 ohm resistor down. What is that? This guy is playing games with us. If we try to look to the problem, he gives us 4 different 3, like line and 3. This is a ground. But what I'm in electric circuits, generally speaking, or in engineering, what you have to do is you have to have a reference for any problem. So, for example, I will choose this wall to be my reference. I'm away from that wall by 3 meters. Peter is away from that wall by negative 3 meters. What's the distance between me and Peter? Because he is an opposite edge. This is the sense of engineering. We have to have reference for everything. And what I did here, I'm playing game with you. I gave you reference. These 3 lines are the ground or the air. It is connected to the bottom, it is connected to the right, it is connected to the left. So this problem looks like that. This guy is 0.4. This guy is 5. This is 3. This is 5. This is 0.4. Because this guy, this guy, this guy, this guy are connected together. Okay? Right, now it became very easy. What do you want? I would like to find the current in each branch. Actually, by inspection, you can solve this problem. If I have this problem could be solved by using a method that we are going to learn in chapter 4, which is low voltage method. But by inspection, I can solve this problem. How? If I have 2 levels of water and they are equal, I'm expecting there is a flow of water from this level to this level, or vice versa. There is no flow of water. So the flow of water is equal to. Yes. If I have 2 different voltage, oh, but they are not 2 different. This voltage is equal to that voltage. Are we expecting there's a current between these 2 points? There is a current? Why? Because there is no difference in these 2 potentials. The voltage is the same. No current is flowing. This is the story here. The basic resistance. If you're trying to look to 0.4 ampere and 0.4 ampere, 5 ohms and 5 ohms, which means there is a symmetry, which means the voltage for this guy is the same like the voltage for this guy. Am I right? So are we expecting there is a current in 3 ohms? So I can say I in 3 ohms is equal to 0 because of symmetry. Since there is no current in there is no current in a 3 ohms, Chris, what is the current in this guy? What's I1? No, the current in a 3 ohms is 0. And this current is 0.4. And this current is distributed between this guy and this guy. But the current in this guy is 0. So the current in this guy is yes. And the current in this guy is yes. So I can say I1 is equal to I2 is equal to 0.4. I will not do anything. But if you would like to solve the problem, you can. You can say summation of current for each node is equal to 0. The summation of voltage is equal to 0. So, if you would like to solve such a problem, what you have to do is you are going to assume current in this guy, and assume current in this guy, and assume current in this guy. How many currents? How many currents I assumed? Then I will say summation the voltage for this loop is equal to 0. Right? So summation the current here is equal to 0. Summation the current here is equal to 0. Summation the voltage for this loop is equal to 0. How many equations and how many unknowns? I will solve them. But if you're trying to use your mind and think a little bit about the concept, we are teaching applied science. We are not teaching pure science. And this is applied science. You have to use your mind and understand the theory of operation. How does this circuit is working? This is what I would like to think about. I don't like you to be like a machine. Write equations and solve them. I don't like you to be like that. I'd like you to think on how to solve a problem. Sit for 1 minute and think. You will find the right answer. But if you didn't think, what are you going to do? You will write 3 equations and 3 unknowns, and you will try to solve them. You need like 20 minutes. But right now, I can solve it within 2-3 minutes. By the way, when I gave this problem to my students, I put 20 minutes for that problem. But some students solved it for 2 minutes. And some students didn't solve it. Yes, what's your question?
What type of the element?
What type of what?
Element. Is the active or the passive?
Both of those are active. Because as if I have 2 separate circuits. So I, which is the current source, in each is active. So there is a problem similar to this in the assignment. So if you try to look to the assignment, because I don't like to waste the time solving many problems, I would like to show you the assignment very quick, because I promised I will try to finish as soon as possible, because it is the first tutorial and I don't like you to hate me. So, but you started hating. So if you try to look to the assignment, this problem similar to what we have already solved. Those are connected in parallel. In parallel with this, what's going to happen to those? Cancelled. So I2 What's going to happen to this? It's cancelled. What's going to happen to those? I4, V2. At the end, I have only this resistor in series with this resistor. Very, very easy. But I'm playing games with you, and I draw parallel things. See, as if you have a table and you are voting for the problem, but it's really, very easy. Let us see the other problem. So problem 2 is similar to what I have already solved. Problem 3, similar to what I have already solved. What is the current in this guy? What is the current in this guy? What is the current in this guy? What's going to happen to this guy? So I will continue talking about the rest of the problems. I still have problem number 5. I don't know if we have time to talk about it or not, but we can talk about it tomorrow or after tomorrow. That's okay. But before leaving, I would like to talk about the lab. So I didn't complete talking about the assignment in the tutorial. I will complete that probably by tomorrow. But I would like to talk about that later. So within 5 minutes, what's needed from you for the lab? I'll answer your question, but let me talk about that first. So for the lab, today, some of you went to the lab, and some of you tried to measure the voltage across the LED, which is the diodes, and I asked them to measure the voltage when the diode lights and the current. And some of you asked me which voltage and which current, and I told them any voltage and the corresponding currents. So for example, if I turn on my power supply by using 10 volts, I would like you to measure the voltage across the diodes and the current at the same time. If you turn on the power supply for 5 volts, measure the voltage and the current at the same time. It doesn't matter for me, but what I need the voltage and the corresponding current at the same time. Are you seeing what I'm talking about? This is what I told them today. The second thing, I told them also it's better to have pictures for your circuit, for your phones. Some of you took pictures, but that's okay for the first step. But later on, it's better to take picture and put it in your report. For the lab, I asked it to have a group of 2. And those 2 will have only one kit from the lab technician. And they will work together. Doesn't matter for me who's going to work with who. If you would like me to put a list, I can. But I don't like to be an ugly guy and ask Andy to work with Chris, and both of them are hating each other. I don't mean anything, but I'm saying anything. So you can choose your partner. I don't mind. Anyone you like to work with, that's okay. If you don't like to work with a partner, that's fine. You can work by yourself. Also, what I would like to mention for the lab, for the assignment, I prefer to submit the lab and the assignment on Brightspace. I don't prefer handwritten papers. Why? Because I'm teaching to 250, and what's going to happen after giving me your assignments, I'm going to give them to my TA, and maybe my TA will lose something. And at that time, we'll say, oh, I gave you my assignment, but I didn't get a mark. But if you posted or if you submitted your assignment through Brightspace, there is 0% for making a mistake like that, for losing your paper. So what's needed from you after writing the assignment, I'm not asking you to use the laptop or the computer for typing your lab or your assignment. You can write on your hand, that's okay, it's acceptable. Take picture and put those in PDF file. I think you did that before, yes, in the previous year, and you will be able to submit it. Do you like that, or you prefer handwritten papers? So bright space, everything will be through bright space except the midterms on site. So, one more thing, sit down please, sit down. 5 minutes and I will complete everything. The due date for the first assignment will be next Monday. The due date for the first lab will be Friday next week. So usually for the lab, I'll give you 1 week. So we did lab 1 today, next week. You will submit it by Friday, not Monday, for the lab. I'm giving you whole week because some of you are going to the lab on Fridays. So I have to be fair. I'm giving them also 1 week. What is needed for the lab reports? Maybe it is the first time for you to write lab report, and I have already submitted guidelines. So there should be a title for the lab, and there should be objective for the lab. Like today, for example, our today's lab is talking about being familiar on dealing with connecting some resistors and diodes or whatever. Write that objective. So you will write that objective at the beginning. It is written in the lab. You will try to modify it. And then you will write the tools that you use. We use breadboard, we use 2 resistors, we use 1 diode, we use 1 power supply, we use multimeter. You will write that. And then you will write the steps. But in very, very quick way, like connected the 2 resistors in series, and then we measured the voltage across each one, and we connected the diodes, and we found that the diode is not working because of the polarity, so we flipped it, and it was working. Then the part for the measurements. So you did some measurements. You will put, I measured V1, it is equal to V2, V3, and so on. And then there will be part for calculations. For the first lab, there is no calculations, I believe. I asked you only to do some measurements. So for the first lab, no calculations. You will write only the measurement values. And then for the conclusion, for example, you were working in the lab and you tried to measure the voltage across the resistor. Or you were trying to measure the current in a certain branch. And what happens? You connected the ammeter in parallel. So what's going to happen to the fuse for the ammeter? It will blow out, which means the ammeter will give you 0 value. You have to comment on that. You will say, I got 0 value for the current because I did a mistake. I connected the ammeter in parallel and it was supposed to be connected in series. That's why I got 0 value. It doesn't matter for me if you got wrong measurements, but you have to explain why. So I'm not asking you to find the correct value. That's okay. Maybe you did a mistake. Maybe you didn't get a time to ask the technician to change the fuse for you, to replace it, to be able to measure the currents. You got 0, so you have to write it. These are the steps. I'm not asking you to write a very complicated report, like 1 or 2 pages. That's okay. Are you seeing what I'm talking about, guys? Don't waste your time by sitting and writing many things. If you are group of 2, I don't mind, you will share the calculations, but you will not share the words that you arrive. Each one is writing by her or himself. And if you are in group of 2, please, each one will submit his or her own lab. But please, don't forget to write your partner. So you are submitting the lab under your name. My name is Hamid. So I will write Hamid, partner X. while my TA is marking, he or she will realize that maybe he is going to see some similarity, which is okay. Hey guys, did I answer any question? All the questions for the lab report? My friend who was asking about lab report? Any question for the lab report before leaving? Okay, I'm so sorry for being late. I'll see you all tomorrow at 10:30. And come to us. Just per second, I will stop recording. So